Hello everyone! The purpose of this video is to describe to you the expectations for your Experiment 7 lab report. So as you know, we worked with the compound Allura Red, and you should now be accustomed to the requirement that you submit two documents, an Excel file and a Word file. So I have a sample Excel file shown here. So what you should do is you should record the concentration of the Allura Red. I have mine in molarity, but you could use micromolar if you like. What I've done with this document is I have shaded in pale yellow the cells where it is permissible to type in the values. The other cells that are not shaded, you should write formulas. So don't do the shaded yellow in your own Excel report. That will not make it look nice. I'm just doing that for the purpose of the for this video. So the other thing you should write down is the Lambda Max that you measured using the LabQuest. So if you move down here to this table, you will need to write formulas for how you calculate the concentrations of your standards. So not everybody did this the same way. So what I did here is the last standard was going to be equal to the stock concentration. I don't have anything recorded here, so that's why it says 0. But remember, we used the stock solution to prepare all of the rest of these standards. So all of these cells should have a calculation in here that reflects how you prepared your unknown, and we should be able to figure out how you did that by looking at your formula. In this cell right here, you will just type 0 because the first standard was water. Okay, moving on to this table right here. So here I have my line S data. So you will carry out a line S calculation where you will your Y values will be the absorbances and the X values will be the concentrations. And when you get the table for the line S data, remember the slope is over in this portion of the table. That's the Y-intercept, and the R squared tells you how good the fit is for a straight line. The closer R squared is to 1, the better the fit. Okay, so in this space right here, you should construct a beautiful plot where you plot absorbance versus concentration. So absorbance on the y-axis and concentration on the x-axis. So you should have a nice straight line with a trend line drawn through your data points, and you should display the equation of the straight line and the R squared value on your plot. Axes should be labeled, all of those nice things for a graph, and you should be sure to display at least 3 significant figures for the equation of the straight line. So moving down here, on this part of my spreadsheet, I have my unknown information. So the Allura Red concentration in my drink was our unknown. So here you'll want to tell us what drink you used. Here you should indicate the absorbance at the Lambda Max. I used 500. That's what I measured when I did this experiment. You might have gotten a different Lambda Max, so you should just record whatever it is that you got. So we had you measure the absorbance of the drink solution at the Lambda Max. For most of the unknowns, the absorbance was outside of the range of the standard curve. So you won't use this value at all, but it's a way of demonstrating why it was required for you to dilute your unknown. So moving down here, what you need to tell us is exactly how you diluted your unknown. Maybe you diluted it 1 to 10, or maybe you used a 2 ml pipette to dilute your unknown to 10 milliliters in the volumetric flask. So here you should indicate the volume of the drink that you used, and in this cell, this will be easier to do the calculation if you record the total volume of your diluted drink sample. So if you took a 2 milliliter volumetric pipette and placed your unknown in a 10 milliliter volumetric flask, you would record it this way. And that reflects how we made the solution too. So you measured the volume of the drink solution using the volumetric pipette, and then you diluted to the line in the 10 milliliter volumetric flask. We didn't measure the concentration of the water. We just added sufficient water so that the volume's total solution was 10 milliliters. So whatever it is that you record in these cells should reflect how it is that you diluted your drink sample. Now, next, you are going to record the concentration of the, you're going to record the absorbance of the diluted solution that you measured using the LabQuest. So don't average that. We're not going to average to the end. So in this next cell, you're going to use the absorbance to determine the concentration of your diluted drink sample using Beer's law. So you'll want to write a formula in this cell right here, and you'll want to copy that formula to these cells right here. But when you write the formula, remember for Beer's law, you need to use the absorbance, but you will also need to use the slope and the y-intercept. So be sure when you write the formula in this cell right here that you use the dollar signs indicate an absolute reference. So the dollar sign in front of the column in the row that indicate the cell address for the slope and the y-intercept. Next line right here. So now that you know your concentration of the diluted unknown, we want to know the concentration of the undiluted unknown. So in this cell, you should have a calculation using the dilution formula, V1M1 equals V2M2, and that's where these values right here are going to come in handy when you will be able to calculate the concentration of your undiluted unknown. So it's easy to get these things backwards, so just make sure that your undiluted unknown concentration is greater than the diluted concentrations, and that way you know you did it right. Now we can average. So we will average all of these undiluted unknown concentrations from our 3 trials. So use the absorbance formula there, and then we will calculate the standard deviation. So again, I expressed mine in molarity. If you want to use micromolar, that's totally fine. All right, so you're going to have a Word file as well. So I have my experiment number and my title and your name, what beverage you used, and the day, and your instructor and the date. So this is an analytical report, so we start with the results. So everything that we asked you to do in the results section will be in your Excel spreadsheet. So you just need to type, please see Excel spreadsheet. Moving on to calculations and interpretations, I have the 4 requirements here for the calculations and interpretations. So some of these things are also in the spreadsheet, but not everything. So for example, in the first question here, you were asked to construct a table that has the name, the color of the Lambda Max, and the color of the light of the Lambda Max for each of the solutions that you measured in part 1. Make sure that Allura Red is in this table. So in this space right here, you can construct a nice table that has all of that data in it. And this is a nice visual to help us see what the relationship is between the color of a solution and the absorbance of the wavelength of light that it absorbs maximally. Going on to number 2, so you were asked in tabular form, report the concentrations and the absorbances for the solutions you prepared for constructing your standard curve. That's on the spreadsheet, so just say, please see Excel spreadsheet. Number 3, please construct a standard curve, so these are the requirements here. So again, the Excel spreadsheet will have the standard curve and the line S data. So you need to say, please see the Excel spreadsheet for the standard curve and the line S data. You should also in this space report the value of the slope, epsilon times L, and the full equation of the best fit of the straight line. So report that here. Moving on to 4. So here, accounting for the dilution, report the concentration of your original unknown solution in tabular form, reporting average and standard deviation. Again, all of that is on the Excel spreadsheet. So you can say, please see Excel spreadsheet for unknown data. Sample calculations are shown below. So for your sample calculations, we want you to show a calculation how you determine the value of the molar absorptivity, epsilon, from the slope, and L, the path length. And we want to see a concentration calculation for one of the trials of your diluted unknown using Beer's law. And again, you just need to show one trial. You don't need to show all 3. And you should show a calculation of the concentration of one of the trials of your undiluted unknown using the dilution formula M1V1 equals M2V2. Again, just show one. You don't need to show all 3. And that's it. You don't need to show the calculation for the average and the standard deviation. And when you are proofreading your sample calculations before you turn in your lab report, be sure that you've used all of the proper units and significant figures. Since this is an analytical report, part of your grade will be based on the quality of your work. So we will be looking at a few things. We will be looking at the R-squared value for your straight line. We will be looking at your standard deviation for your drink solutions. That's another indication of precision. And both of those are a test of your skill in the laboratory for carrying out the dilutions. We also have a publication that indicates a range of the concentrations of the Allure Red in these drinks. So we will be assigning you an accuracy score as well. So I'd like to encourage all of you to use your sample, present your sample calculations using the Microsoft Equation Editor. I think most people are doing that, but if you haven't learned how, that's a skill that we'd like you to have. So there is on Sakai a video that explains how you should use the Microsoft Equation Editor. So if you have any questions, please visit your instructors during office hours. Thank you for your attention, and we look forward to seeing your work.